So we are now looking at something very illuminating. Now, with engineering and electronics, this is the area we're going to go into now. I think you'll agree with me that, you can pretty much, find, that everything is controlled electronically or run by electricity. So, there's plenty of interesting and well-paid jobs out there for you if that's the area that you're thinking about going into. Now, computer programming is relatively easy and it's very interesting. If you've never tried it, you're going to get the opportunity to do so later on. And I had a little go myself using this equipment. It's called Scratch, and I'm very pleased to introduce you to Mr. Moonlander himself. It's Robert. Hi, Robert. How you doing?
Hi, Faye. I'm doing fine. Thanks very much.
Yes.
And welcome to Moonlander.
Yeah, great to have you here.
I like the look of the ice cream. I hope she has some left over. Well, the aim of this activity is to have a bit of fun programming a Moonlander. I'm an electrical engineer. I'm sorry I can't be with you today, but that's because of the coronavirus and so on. So we're going to do some programming. So don't worry if you can't complete everything on time, because you'll be able to download the program and also the details of how to do it from the website later on. But if you need to, while I'm just talking about electrical engineering, how about logging into https://.scratch.mit.edu.
Right.
Your computer set up.
Robert, I think we'll pop that link into the chat in case people don't have it.
Great.
My able assistant, Julie, to pop that into the chat so people can log on in case they don't have it.
Right, I'm going to share my screen now. So we're going to go over to Moonlander screen. I hope. Share.
Here we go.
There we go. Can you see that okay?
Yes, thank you.
Great. Okay, so what we're going to program is how to land your rocket ship on the moon. But before that, I'm going to talk about, if I can get this thing to go forward. Dear, dear, got a technical problem here.
Here
we go.
There's going to be.
We're going to have a quick look at the many different types of jobs that engineers can do. And I was saying earlier, get set up with your computer ready to start programming by typing in this URL here. Right, there are lots of different types of jobs you can do, and one of them is to work in research and development. So in that case, you'll be working in a design lab, designing new products, or you might be trying to make new discoveries. And of course, electrical engineering covers a massive range of different industries and organizations, from universities to the biggest companies to the smallest companies. And you could be working on anything from the latest iPhones to a new tablet computer, or you could be working in transport. Electrical transport, almost all cars now are controlled by computers. And there's a huge industry in the power industry, of course. And the nice thing is you get lots of opportunities to travel around the world. So you can travel the world and get paid for it, so to speak.
Nice.
Other areas, there are lots of different areas which you can work in within electrical engineering inside one particular company. So you become the company, you could work in installation and commissioning, that is going out to the client's sites and setting up the equipment, or advising the customers on what they should do, or fixing the equipment if it's got problems. And that way you learn management skills, you learn leadership skills to organize other people, and you learn about the company's products. So it's a good way to get promotion in the future.
And can I say, Robert, when I go into schools and sort of do motivational workshops and stuff like that, and I always ask young people, what do you think some of the top skills are that employers are looking for? And they say skills like the qualification, and networking and working in a team and being able to think outside the box. All those things are just top of the list, aren't they?
Absolutely, yes. And certainly computing is one of them. And if you're interested in computing, artificial intelligence, and up and coming industries are the new 5G system for mobile phones, and of course electric cars, and of course space travel. And that's what we'll be looking at in a moment. So you can be working from anything from satellites to submarines. So there's a huge choice. And remember that you're at school for about 10 years or so, but you could be working for 50 years or more. So make sure you choose something which you really like doing.
Absolutely right.
I'll just tell you a little bit how I happened to get interested in it, because it might help you in a way. One of my friends at school built a crystal set, and this is a radio which doesn't need a battery. And I thought, heck, that's rather interesting. So I then went on to build 1-valve and 2-valve radios, similar to the modern transistor radios, so that I could listen to the pop music coming from Europe on Radio Luxembourg, which was great fun at the time.
I remember that radio station. I used to listen to it late at night when I should have been asleep.
It was great fun, wasn't it? Yeah. But the point I'm making is it's very useful when you're your age at school to build models and try things out, because you get to know what you like doing, and also it helps with your studies. And it stays with you for the rest of your life. So the skills I gained from making little radio sets when I was at school helped me for the rest of my life. I was going to show you this video now, but I'm going to put it on at the end, hopefully, because of technical problems or one thing or another.
So sorry to cut into you, but I don't know if you know this, but we have over 400 people participating.
Wow.
I know, and the chat is already alive. So I'm going to be dipping in with questions as they come in. And just to say, somebody's already asked, can you show us the radio if you still have it? Do you
I've got lots of radios I could show you. Yes, lots of radios. Okay, well, I'll try and dig one out a bit later on.
Oh, thank you. And that's from Armin Sharizi. Thank you.
Oh, hi. Well, I'm glad you're interested in electronics, because it does, it's so important in modern life, isn't it? What we're going to be doing now is programming a Moonlander. And as you can see, I've said here, programming is very important for engineering nowadays. And it's very widely used for simulating, i.e. making sure that your designs work well and optimizing the designs. And in this case, we're going to be simulating how to program a rocket ship on the moon. So start up a new Scratch project by going to https://scratch.mit.edu if you haven't already done, and then click on Start Creating. And the first thing we're going to do is add a backdrop. So what you have to do is click at the bottom left-hand side of the screen here, which says Backdrops.
And I created a desert for me. That's what I went for.
A desert? Wow.
Sahara.
Right. Well, when you click on backdrops, it brings up a little sort of menu of different items here. You want to click on the bottom one there, and that's brings up the backdrops. And you want to choose Moon, or click on space and type space in the top left-hand corner here, and then double click actually on Moon, and that will add the moon backdrop to your computer program. So we're setting up the initial conditions. If we're in the engineering department, we're setting up the initial conditions for our simulation.
Robert, I have a little question for you.
Yeah.
It's from Atisha Jan.
Yeah.
What qualifications would you need to become an electrical engineer?
What qualifications do you need? Well, ideally, you need to do maths and science at school, preferably physics would be a great help. And then if you want to become a chartered engineer, you want to aim to go to university, at least try and get A levels, because that way you can easily get into the apprenticeship scheme. And one of our most famous scientists or engineers ever, Michael Faraday, who made discoveries which changed the world, actually started as an apprentice. So it's a very good way to start, and you can talk to people in the company in which you're working and say, how did you get involved in this? And they'll help you. They like to help young people.
Oh, that's great. That's great, because a few people are asking, is engineering a hard job?
It varies an awful lot. I was saying earlier, you can work in many different areas. You can work in sales, for instance. So from that point of view, it's not technically hard. You need to know the company's products and travel around. And like installation and commissioning, you can travel the world and get paid for it. So it's like having two salaries.
It's like you were saying, though, if you're interested in something, because you could work for 50 years, then there's a role for you in engineering, isn't there?
That's right. Yes, there's a whole role. You could, because the technical schemes, technical landscape is changing all the time, and we're now looking at, say, electric cars and the 5G new mobile system. There's always something new coming along, and as you gain experience, you become more and more valuable to employers and the rest of society, and you can do things which help people, things like that.
People haven't got on there yet. They're asking for the link.
Oh, right.
Really can type that into the chat, please. That would be awesome. So do look out in your way.
That's for the link for Scratch. Is that the link for Scratch, Vail?
After, yeah.
Well, I'll go up a page. Let's see. Here's the link here. Can you see that all right? HTTPS, then : / then scratch.mit.edu. Okay. And then I say, once you get up, we need to put the backdrop on here. So I better give you a bit of time to do the backdrop.
While they're doing their backdrop, Jamin Jethwa was asking, what qualifications do you have, Robert?
Well, I went to university, so I did electrical engineering electronics degree. And then I went to work for Rakel BCC. That was my first employer. They were making military man-pack radios in those days, the type of radios which don't stay tuned to one channel. So they were called frequency hopping. So the enemy couldn't tune in and listen to what you're going to be doing next. So that's how I got going. And then later on, I went to work for the BBC, which was great fun on outside broadcasts. And I really enjoyed that, and so on and so on.
You know a lot about broadcasting, and there was an earlier question about radio valves. I need to find it. Vivian Verma was just saying, what is the difference between one valve and two valve radio?
Right. Well, the valves are used to making the signal stronger. When the signal arrives at your radio set, it's a very, very weak electromagnetic wave signal, and we need to make it stronger in order to drive your headphones and drive loudspeakers and so on. So a two-valve radio makes the signal stronger, and it's less critical to operate in actual fact. Okay. I don't know if that operates there. So I hope you've got your Scratch up going. As I say, the first thing you need to do, click on Create. Once you go to scratch.mit.edu, click on Create, and then click on Backdrops here. Click on the little magnifying glass icon, and then click on Space or type Space there, and you'll get the moon backdrop. So I'll go back to the next page.
This now, Robert, and some people I think are going to do this after, and they're like Woody in Melbourne, for instance, is asking how easy is Scratch to use? Yes,
I think Scratch is very, very easy indeed to use.
I used it, and I'm years old. It's easy.
It's easy to use, yeah, and it's great fun to play with. There's lots of online programs that you can play around with, really fascinating programs too. The next operation we need to do on our program now is to add some sprites. Sprites are the bits and pieces we have on the screen here. So the first thing we're going to do is to add the Earth on the horizon here. So click on the sprites icon here down at the bottom, and that will bring up another menu, just like the previous one. I'll just go back a page. So it'll look a bit like this, but it'll have sprites. So type Earth in the top left-hand side there.
Can I ask you a quick question?
Yes.
Toby Cloves is asking, can we code on Unity or Codo instead of Scratch?
Well, I'm not familiar with them, I'm afraid to say, so to be honest, I can't answer that question. But I'm sure you probably can do similar type of things. You can type in many different programming languages. Scratch, though, is very easy to use. That's why I chose it for this demonstration.
It must be easy because Abhidra Joshi says he's done it. He's done.
Well done.
But somebody else was asking, I think it's an anonymous one, can you program a real world robot, i.e. a drone, using Scratch?
Yes, I think there is a system called S4A, which means Scratch for Arduino. And Arduino is a tiny microcomputer which you can use to control things.
Okay.
And I did try it a few years ago, but I haven't tried it recently. And it's probably more complicated than using the on-screen version, but it's probably doable, I would say. So have a look at S4A. Do a Google search on S4A. So once you've got your Earth onto the screen, set the size here to 35%, just the little size box in the screen here, type 35 in there, and then drag the Earth up to the top of the horizon here. So we've got a nice space scene there. Now we're going to want to add Pico. He's going to tell the users how to operate the program. So click on Sprites again, and then when you get to the, I'll go back up to this screen here, type Pico in there, in that corner there. And you should get Pico onto the screen, and then set his size to 35% again, and drag him down to the left-hand corner of the screen. And then for the next sprite, which is the rocket ship, the most important bit, click on Sprites again. And then in this part of the screen, type rocket, and you'll get the rocket ship onto the screen. And then set its size to 35% again, and drag it up into the middle of the screen there. And then we should be ready to go. Keep our fingers crossed. Now then.
David May was asking, how did you get the idea for this?
How did you get the ideas? Well, in the old days when I was at school and university, the computers were very primitive. So we used to program in different languages, Fortran and BASIC, and we used to program Moonlander in this Fortran or BASIC, and it was great fun to play.
Wow.
But things have advanced now. Scratch is much more fun. You get a nice pictures and everything else.
William David's asking, are you going to do coding whilst creating this model?
Well, you'll see coding is done by using drag and drop technique. So I'm going to explain that now, so you'll see what I mean by coding. So it is coding in a way, but it's a very easy way to do it. So it's a very good way to learn. As I say, when you're writing a program for other people, it's very useful or very important to tell the user exactly how to go about it. So we're going to tell the user how to play the game now. So the first thing we do is go over to the left-hand side of your screen here and click on Events, and drag this when green flag clicked into the programming area. Make sure you've got the programming area here, because you'd click on code if you haven't. So drag the green flag into the center of the screen. And now we're going to code on Pico. So if I go up a page, click on Pico there, that's important. And make sure that the green flag is on the Pico screen. You should see Pico in the top right-hand corner there. So to tell the user what to do, we go to the Looks section, click on there, and then drag out Say Hello for 2 seconds and put it in the bottom there. It starts off by saying Say Hello, so we change that to press the space bar to start. So we're telling the user how to start the screen.
Can I squeeze another question in while you're doing that?
Yeah.
Eid Islam was asking, is engineering included in every technological product?
Well, of course it is, doesn't it? We have to do, somebody has to do the design for it. So engineering is included in absolutely everything. And there's so many different areas which you can work in, which is nice, like sales, I say, or you can work even on the financial side if you like that sort of thing, or you can work in design.
Right. So a question from Adithra Krishran, who was saying, is it related to astrophysics? Then I guess the answer would definitely be yes.
It is, yes. Of course, there'll be other specialists working in that area as well, particularly physicists and people who are working in rocket science and so on. And we're very lucky in the UK. We've got Aerobus, which if I can show you the video later on, Abby Hutt is wearing. Sorry, are you going to say something, Fayon?
No, I was just thank you. And Vikram Kohan was just saying, how many different areas are there in engineering? And, you know, I know from doing, you know, different fairs that there are hundreds of different types. But what would you say?
That's right. That's right. There are just hundreds of different types. There's chemical engineering, mechanical engineering, electrical engineering, electronic engineering, programming, and there's space engineering. And so the list goes on.
It stems off from there. Within each of those, you've got loads and loads of other strands, haven't you?
In there, as I was saying, yes, you've got design, you've got research, people who are trying to make absolutely new discoveries. And the employers are quite different. The researchers tend to work for universities or the government or very big companies, something like that. So this is just a little explanation. As you approach the moon, the gravity starts pulling you down. That means your velocity downwards keeps increasing and you approach the moon faster and faster. You have a limited amount of fuel. So if you run out of fuel, the lunar lander is going to crash on the surface. So we've got to prevent that happening.
Why not? Question. I'm so sorry. There's just
carry on.
I love this. There's a question of, is it physical work or more static work? And I think you kind of answered that already with regards to how many different types of engineering there is.
Yes.
But Abhidra Joshi was asking, what does an executive director do in the field of engineering? Would you know?
Well, typically you're sort of planning the new products. It depends. If you're a technical director, you'll be looking very much at the technical side of things. And if you're a sort of executive director, you're probably looking at the financial side of things. You want to make sure you've got good products, which will keep everybody in employment. And probably one of your most important roles is leadership, going around and talking to everybody. As you get more senior, it's more difficult to know what's happening on the ground level, you might say. Yeah. So it's very important to go around and talk to everybody on the shop floor if you're a senior guy and say, what are the problems? You know, could we be doing anything better? Yeah. I think the Japanese are very good at that sort of thing, and the Germans.
It's a great way to be a manager. You know, it's not like you're up here and everybody's down there. You've got to come in the middle and make sure that you are communicating, because that's what makes everything work so well.
That's right.
Woody Melbourne is also asking, what inventions have you made while you're kind of doing this?
Well, you tend to specialize in certain areas. So I was working on synchronization typically. So working on synchronization of the latest digital video and audio systems. We also worked on collision avoidance radar for cars, which will be important if cars become sort of self-driving.
They are.
Things like that, and GPS satellites. We're looking at synchronization of the new Galileo satellites, which have gone up fairly recently, you know, working on that. So coming up with patents for those, that were the last new ideas I came up with.
Thank you.
Other people helping me, obviously, not the only one. So as you burn the fuel, the rocket gets lighter, so the pull of gravity is less, but we're not taking account of that in this particular simulation. By firing the rocket's motor, you can slow the rate of descent, but this uses up fuel, so you've got to make sure you don't run out of fuel, otherwise you'll crash. And you want to touch down on the moon surface nice and gently. So we now need to tell the operator how to fire the rocket's motor. So we'll click on Pico still and drag another say hello for 2 seconds, put it in the bottom underneath the press space bar to start. And then instead of hello, type in use the up arrow key to fire the rocket motor and slow your descent. Now, it's a good idea when you're programming to check everything's running okay. So click on the little green flag there and make sure what happens is what you're expecting to happen, because it's very easy to make a mistake.
Cross fingers.
So we're now going to model the fuel usage and the descent. So we need to program the rocket by adding a method to fire the rocket's motors. So that will use fuel in the rocket and slow its rate of descent.
Can I ask more questions when
yes.
you point where they're doing stuff?
Yeah.
Good time? I've got so many questions.
Is that okay? How are we doing for time? Are we all right?
We're doing okay. We've got about 12 minutes.
Right. Okay. So,
and then we'll do a Q&A towards the end.
That's right, yes. And I say everything will be up on the website, hopefully. So if you get stuck, you know, you can do it later and have fun later. So we're going to start programming the rocket now. So click on the rocket at the bottom of your screen here and drag and drop when space key is pressed block from the event section. So there's the event section, which is light yellow, and drag out when space key is pressed. We may have to change it to up arrow key is pressed. So when you drag it out, it'll probably say when space key is pressed, but click on the little arrow here and that will change to when up arrow is pressed.
It's really self-explanatory, isn't it? It's so
It is. I think it's very, very nice from that point of view. You can concentrate on the main things and you have a bit of fun seeing the pictures too. Now then, we're going to add an if-then statement. So programs are controlled by if statements, which make decisions, and repeat statements and so on, which you'll learn about if you do computing at school. But first of all, we need to create a couple of variables called velocity and fuel in order to track the rate of descent and how much fuel is used. So first of all, drag out an if-then statement from the control block and put it in the bottom there. And then go down to the variable section here and click on make a variable. And make your one variable called fuel. And then make a second variable called velocity. So that will give us two variables, one to check the amount of fuel left and one to check the velocity.
Yeah.
Now we want to make sure we've still got fuel left, so we need to make decisions. So drag a green operator block from out of here with angles on, and it wants to have a greater than sign in the middle. So that's like a right arrow, you can see it here.
Yeah, yeah.
And then go to your variables and drag a fuel variable and put it into this left-hand side, and then put the decision block into the if-then-else statement, and you'll come up with that. So finally, if the fuel is greater than 0, then you can obviously fire the rocket's motors. So we'll change the velocity. So we'll do change velocity. Go to the variables block again and drag out a change velocity by. If necessary, click on the little down arrow to get the velocity here and type 5 into there, change velocity by 5. That's the amount we're going to change to slow the Moonlander's descent. And I also want to change the fuel. So drag another change block out and change it to fuel, change fuel by -5. So when the up arrow key is pressed, if the fuel is greater than 0, we can fire the rocket and change the fuel level. Right.
Do a countdown before you launch.
Well, yes, I'll show you what that says. I'll show you how that, once you press the space bar, you'll see you'll get a little message saying, let's go. Right, so we're going to model the descent to the surface of the moon. So we've got to first add an event flag. So we're still in the rockets, coding to the rocket now. So drag a when green flag is pressed block from the left-hand side of your screen into the center of the screen. And we're going to make two more variables now, one called ypos for the position up and down on the screen, and one called xpos to record the left and right motion, although that won't change in this case. So make two variables, one called ypos and one called xpos. And then from the left-hand side of the screen, drag it out and put it underneath the green flag, drag out a set ypos to 140. So you have to click on the little down arrow to use your new ypos variable. At the same time, go to the left-hand screen, drag an xpos, set xpos to 0. So you may need to click on the bottom there, make sure you've got xpos there and ypos there. Make sure you've got 140 here and 0 there. And finally, we want to make the rocket move. So we go to the left-hand side of the screen and get a motion blue block, drag it out and put go to XY. And in the XY, use your two variables, xpos and ypos. So that's the coding. You should end up with that, a separate little block like that.
Wowzers.
So later we'll need to accelerate the rocket down towards the surface of the moon to mimic gravity, and we'll use a repeat until loop, which operates in 1 second steps in a moment.
Okay.
And then later we'll need to repeat that.
Robert, we've got 7 minutes until we finish, and I've got a heap of questions for you.
Well, I'll keep going fairly fast, but you can ask the questions at the same time, of course. So we've got to model the fuel usage now. So this is when space key is pressed. So we're still coding for the rocket. So drag out a when space key is pressed from the event side. And we're going to initially set the velocity. So from the variable side, get a set velocity to -10. Remember, the velocity is going to be changing as time goes by, but you'll see how that's done in a moment. And initially set the fuel to 140. So from the left-hand side here, variables, drag a set fuel to 140. And then as you were saying, we've got the countdown here. So once the space car is being pressed and these two, the velocity and the fuel at the starting initial conditions are being set, we say, let's go. Right, so let's get cracking. So do an initial test now. Say always do a test as you're doing your programs, make sure everything works correctly. So click on the green flag at the top of the screen here and make sure everything happens that you expect to happen. Pico should say, give his instructions, and everything should move to the starting position. So now
while they're doing their test, can I ask you a few questions?
Yes.
So Nidarko wants to know, what qualifications do you need for civil engineering?
Civil engineering, I'm not, to be honest, being an electrical engineer, I'm not quite sure. But if you have an engineering degree, particularly a mechanical engineering degree, I would think, but I think there are civil engineering degrees, I'm not sure. But physics would be a very good one to do.
Yeah. So
physics degree.
The question from Sean Sarishny, I think, are there multiple degrees for engineering and which are they? That's probably not your expertise to answer that, but there are so many organizations out there. Where would you start? Where would you begin looking?
Well, I should certainly look at the university websites. If you're thinking of if you'd like to go to a particular type of university, look on their websites. They're very good. And they have lots of information on what sort of degrees they do, and choose one that you like. If you're not quite sure which area you want to do, I should choose a general degree like physics, which is a very good degree. But if you're more specific, if you definitely want to do electrical engineering, electronics, then obviously we go for that. And similarly for civil engineering or chemical engineering or whatever. So, and we're going to add this repeat loop. We've just done the top bit here. So we said, let's go for 2 seconds. So we're going to add a repeat until block. So go to the left-hand side of the screen and bring in a repeat until block. And it's going to repeat until ypos is less than -105. So you want to get a green decision block, which has a less than sign in it, and drag one of your ypos variables, stick it into the left-hand side, and type -105 into the right-hand side. And this is a repeating loop. So to mimic the velocity downwards, we're going to increase the velocity downwards by -5 every second. And then we're going to move the rocket ship to its new position. So drag from the variables block, drag a change, and then click on Y-pos and insert your velocity variable into there. And then from the left-hand side, drag in a change velocity this time by -5. And then from the top left-hand side, the movements block, go to, and then add in X-pos, Y-pos. And then from the control section, and this is sometimes a bit tricky to find, drag in a wait 1 seconds block. I don't know how we're doing for time, but I'll have to crack on, I think.
We've got a couple of minutes, and I've got about 1,500 questions.
Oh dear, I'm sorry. Anyway, send in your questions, we'll answer them all for you.
Okay.
So this is modelling the rocket's landing. This is the very end of it here. So it's the very end here. You've just done that bit there. So after the repeat loop, add an if-then-else loop. So from the control section, add an if-then-else loop. We need another decision variable here. So from the operators block, drag in a green greater than, and then put velocity in the left-hand side. If the is greater than -50, then we use a looks block to say, well done, you landed safely. On the other hand, if your velocity was greater than that downward, you can say, wow, you crashed. Or you silly idiot, you've just blown up $1 billion or pound rocket.
Whoops.
And that's the final slide apart from the videos. So test your green flag to see if it works correctly so far. And think about how much fuel you need and how you could make it more difficult for other people to play the game, and what are the variables involved, what else you could add.
Wow. Right then. So yeah, the students can really go crazy on this, but I have some questions to ask you. So I'm going to send them to you. If you could give me very brief answers, we'll do our best to get through as many as we can before we move on to our next speaker. So Fayaz Shahil wanted to know, how do you get the simulator accurate?
How do you get the simulator accurate? Yes, well, that's by taking very careful measurements and calibrating your instruments before you take the measurements, so you know what the variables are. We could, measure the mass of the object. In this case, the Moonlander. I think I looked on the website. They're about 2,700 kilograms.
Wow.
And you have about 2,700 kilograms of fuel. So you'd know those as actual figures, you might say, which you could use.
Okay, another question. Arman Shirazi was just asking about your friend from earlier who made the radio. Was it a school project, or was it just something he or she was interested in with regards to engineering?
It was just he or she was interested in them. He used to love making things like model aeroplanes they used to make out of balsa wood. And he had to make up this little radio, which didn't need a battery, and you could still make them nowadays. They're great fun. You need a long aerial, a long wire, in other words, to pick up the signal.
I hope this question for Ali Mirza was asking about how you make the sprites smaller.
Yes.
Double clicking wasn't helping for them.
No, that's right. So to make that slight sprawl, you need to click on the sprite. So it's the rocket sprite. You click on that part of the screen here. And then in the center, just below the picture, it says size. And to the right, there's a little entry box there. So you type in the percentage you want to make it smaller. I've put 35% in my screen. That's how you do it.
Okay. So with regards to people that might be using Python or other things, you're not using that particular one, but for the information that you've done today, everything you've done today, the schools have received this, the codes.
Great.
Link, and so you should be able to go back over that yourself and ask teachers or parents, friends to help you. And it's not even about getting it right, it's about experimenting, isn't it?
It is. It's all great fun, and I'm very glad to have the opportunity to tell everybody about it, and also to watch the ice cream video. Look forward to watching the next one. And thank you for today.
Well, before you go, I'm going to see, can I just squeeze in a couple more questions before you
Yes,
go?
of course you can, yeah.
Wonderful. There's so many that have come through. So, Bilawal Chowdhury, please send your question again so I can ask it, please, because when I say there are hundreds coming through, so yours has slipped through the net, but hopefully I'll get to it in a minute. Okay. I think it's Fayaz Sakiel is asking, when they do simulations for real life, like for instance when they do NASA and they use their rocket, how do they know it's accurate?
That's right. Only by taking measurements, maybe doing small scale measurements on models. Like we're actually doing a computer model here, but you could actually build a model and take measurements. In the communications area, we would simulate a communication channel and then add noise to the channel, things like that. But you could also measure it electronically.
Okay. Bilawal, I found your question. They were just asking who invented electronics?
Well, of course, it goes back to the ancient Greeks, I think. There's a chap called, I forgot what his name was, Magnet or something, a name rather like that. Okay. And he found that the nails underneath his sandals used to stick to a rock.
Oh.
And that information, I think, went to China, and they invented then a magnetic compass. Wow. And the information then came back to us, and then we developed it in Europe, in Italy, France, the Netherlands, and in the UK. We all took it further.
Fantastic. And somebody else was asking, you can see the actual code, bracket, not drag and drop, by clicking on a button somewhere. Oh, they're answering somebody's question. Thank you so much for that. Somebody else is asking, is it possible to change the hitbox of a sprite? You can set the hitbox to Godot and many other softwares, but you don't know if it's possible in Scratch. Is that true?
I don't know. I'm sorry, I can't answer that one. I don't know.
I'll get to a couple more questions because you didn't invent Scratch yourself. It's just something that you've chosen to use because it's nice and easy. And here we go. Let's see. Right, okay. Right. Okay. Right, yeah. Apologies for asking questions whilst the actual experiment is happening, but there are just so many. So thank you for your feedback on that. I don't know who sent it, but thank you. But there's so many questions. I don't think I'm going to get to all of them. So can I ask you, if anybody has any other questions about this, is there any way they can ask them to you?
Yes, I think if you send them by email, I don't know.
Are you happy to?
Yes, I mean, send them to my email, or maybe use a different email address. I don't know.
You know what we could do? If they could send them through to us.
Yes.
Enjoy Science, Enjoy Sutton, then we will get those to you because I feel you're probably going to get about 300 questions.
Oh, good. I'm glad to hear that.
So I will end with one more question. One more. It's from Sebastian Sorisco. He says, what is your favourite part of engineering?
Well, it's coming up with new ideas is the favourite part, and seeing something new working correctly. That's great fun. You get a tremendous sense of achievement when you see something working well.
Brilliant. Robert, I feel we could have more than an hour's session, 2 hours session with you. It's been really fascinating hearing everything that you do, and thank you for taking the students through Scratch. And of course, if they want to go on and try it out as many times as they can, then the link is there for you. So please do that. So thank you, Robert.
Right. Thank you for all your help. Bye.
Thank you. Bye-bye.